This, 9.6, solving rational equations, is actually the last lesson before our test on Friday. So, this is the last lesson, and then we're going to review Tuesday, review Thursday, test on Friday. So first off, when we take these rational expressions and we put an equal sign in between them, you're always going to test your solutions or check your answers. So you're going to test your solutions because extraneous solutions may be produced. Extraneous, the word extra is within that. Sometimes you might get a solution that actually doesn't fit our domain. When we talk about stuff that doesn't fit our domain, we're specifically looking for the values that make our denominator 0. So going back to that vertical asymptote, going back to those graphs, what makes the denominator 0? So two ways. The first way that we're going to do is we're going to find the LCD, least common denominator, and that's on everywhere. So even after the equal sign. Everything before the equal sign and after the equal sign, we're going to look for the LCD. We're going to get a fraction, get every fraction to actually have the LCD. And then we're going to just zoom in on the numerators. If you have all the denominators being the same, then that means their numerators have to all be the same. So let's see how this is going to pan out. In the first one, if you look at all the denominators, let's look at what do they share, what do they not share. So the LCD is 2x. My goal is to get the denominator on the left to be 2x and the denominator on the right to be 2x. So you've got to figure out in every single equation or every single fraction what is its denominator missing from the common denominator. So in the first fraction, we're missing the 2. So we multiply the 4 times the 2. We get an 8. We're missing the x from the second fraction. So I'm going to have 5x. And then we're missing a 2 from the other, or the last fraction, so we get negative 22. So after zooming in on the numerator, subtract 8, you get 5x equals negative 30. Divide by 5, we get an answer of x being negative 6. Now the other strategy is, you still find the LCD, but you multiply every term by the LCD to clear out the denominators. So because we're clearing the denominators in the end, it's almost like clearing the denominators in the beginning. So this is what it looks like. We completely distribute 2x, the least common denominator, to every piece. If you multiply the first fraction by 2x, the x's cancel. And you're left with the 2. So I just want to show you what it'll look like. So if we take 2x times 4 over x, you're going to see that the x's cancel. And then if you multiply through by 2x with the second fraction, the 2's will cancel. And if you multiply through on the last fraction, the x's cancel also. Leaving you with, so if we clear out the denominators along the way, we're still left with this numerator portion that we see on the other side. That 2 times 4 is, well, there's the 8. The x times 5, well, there's the 5x equals, well, wait a second, there's negative 22. So we still get the answer, x equals negative 6, just in a different way. So in this next one, the least common denominator is x minus 2. What I'm going to immediately do is multiply everything by x minus 2. To show my work, since it's notes, multiply the first fraction by x minus 2, the 7 times x minus 2. Oh, whoops. Hold on, my notation's off. It's equals 7 times x minus 2. So this way I see, wait a second, these denominators, or first denominator is undone, and that last denominator is undone. leaving us with 5x equaling, you can immediately distribute. And it's cleaned up. I get, let's see, move the x's to the left. I get negative 2x equaling negative 4. Get it a problem of x's 2. We need to recognize, okay, what was the domain? The domain in this problem, if I look at these denominators, in order to not be undefined, I can have any real number except 2. So there's the red flag. That's not good. We solved and got an answer of 2, but technically it's not a solution because it makes the problem undefined when you recheck it. So this is a no solution problem. I'm going to go through the reasoning why one more time. These denominators are what you need to check when you get a solution. Because some of our solutions will be called extraneous. They're what you get algebraically, but they're not a true solution. So this x squared minus 1 breaks down into x plus 1, x minus 1. So what they have in common is x plus 1. What they don't have in common is x minus 1. I'm going to multiply everything by the least common denominator, x plus 1, x minus 1. So when you distribute your least common denominator, we're going to be left with a lot of things. We're going to have to double distribute. This is probably, if I'm doing a problem in homework, I probably wouldn't write down the previous step. So those of you realizing, if you have a denominator, something should always cancel, what are you left with? This is where I'm at. So I also want to stress, sometimes it's nice if you know x plus 1 times x minus 1 is going to develop a difference of 2 squares. You may not have to do so much thinking. I'm just going to, instead of have x plus 1 times x minus 1, just going to write x squared minus 1 so that way I can distribute a little bit easier. We have to travel back to old strategies. Multiply, add, bottoms up, greatest common factor. The bad thing is none of those work. Yeah, my bad. Thank you. So it does do multiply, add. Oh my gosh, this makes it so much easier. I thought this one was going to turn out to be a quadratic formula. I wouldn't make you do quadratic formula on a test. I've already tested you over that knowledge. You just got to realize it still exists out there. X equals negative. You got it. So yeah, multiply, add. We get x minus 5, x plus 2. And we get 2 solutions. 5 and negative 2. But you got to check the domain. Like, do these fit in our domain? Because of this, okay, so we check our answers. And both of them do fit our domain. So both of them are a solution. So next one's on you. I have full confidence in you that you can find the least common denominator. You can distribute it. And you can figure out, do we have a solution or do we get a no solution? First off, LCD is x minus 5. In the first fraction, the denominators reduce, or the denominator cancels, so we're left with the numerator 5. In the second fraction, denominators cancel, so we're left with x. In the last fraction, well, we have to distribute x minus 5. So after distributing, getting like terms together, we realize we're down to a true statement. Because it is a true statement, we say all real numbers. Some of you put down just the bolded R, which is okay. Because I know if you were to take a standardized test, you would select the answer of all real numbers. Or you would type into the college placement online test all real numbers. Whoopsies. So recap, we do have to pay attention to that domain. It's not technically all real numbers. There is one value that'll make something undefined. So it's any real number except 5. So the last two have some tricks to it. First off, number 4, the common denominator. They look similar. This is like that warm-up last week. I can't remember what day it was. But last week, someday, we looked through, hey, what happens when you have, they look like opposites, really close. So what we're going to do is we're going to adjust the second fraction. We're going to adjust this fraction because it looks like this one, just the opposite. So here's how I'm going to adjust the problem. I'm going to have it negative x squared, and instead of 1 minus x, it's now x minus 1. Now this is like strategy 1. You have the same denominator, so we're going to zoom in on the numerators. Let's go through this strategy, though, because you can't just divide by an x. Don't do that. You're going to lose an answer. So add x squared to the other side and set it equal to 0. And we have two possible solutions, either 0 or negative 7. We've got to check our domain. So because we just can't be a 1, these are it. These are our solutions. So the next one is hard because the common denominator, well, none of these denominators are similar. None of these denominators share anything. So it's the product of all 3 of them combined. The least common denominator is all 3 of them combined. Because I don't want to write down a whole bunch of work, I'm going to have to visualize what cancels. So because the first fraction has the denominator x plus 2, that means its numerator 1 will be multiplied by x minus 2 and x plus 1. So the next fraction, taking its numerator times the other 2, denominators it doesn't have, and then I'm going to take 2 times, here's the challenge, I would probably write down x plus 2 times x minus 2. Those of you who are good at remembering, like, wait, x plus 2 times x minus 2, that's a sum and a difference of the same 2 terms. So they're going to turn into the difference of squares, x squared minus 4. Because it's notes, I'll write it all out. So let's check our answers with mine.